Previously in this course, when we dealt with the trigonometric functions, we usually used a calculator to compute their output values. However, sometimes in math we're expected to write exact values for the outputs of trig functions, so values that contain like square roots and fractions instead of computing their decimal values with the calculator. Now this might seem like a lot of extra things to memorize, but we'll cover some techniques that help us think about this and make it a little more intuitive. So, in this video we'll cover the sine and cosine function outputs when we're looking at a right triangle that has an interior angle measure of 30 degrees, and we'll also look at 60 degrees because these two things are dealing with essentially the same triangle. So we have a right triangle here. We'll deal with this 30-degree angle first, and we have a hypotenuse that is 1 hypotenuse length long. Now without going into a proof, one very convenient fact about 30, 60, 90 triangles is this shorter side length is always 1/2 hypotenuse length long. So if we have a hypotenuse that's 1 hypotenuse length long, the shorter side is always half of that length. Just a very convenient fact. Now if we look at this longer side, or the horizontal leg in this case, we'll just say it has a length of n hypotenuse lengths, and we'll find the value of n. So the Pythagorean theorem tells us that n squared plus 1/2 squared is equal to 1 squared. And 1 squared is just equal to 1, and we'll simplify this a little bit. So we have n squared plus 1/4 is equal to 1. All I did was squared the 1/2 and squared 1, which then tells us that n squared is equal to 1 minus 1/4, which is equal to 3/4. And therefore, n is equal to the plus minus square root of 3/4. Since we know we're dealing with a positive value for a side length, we're just looking at the positive value. Now, square root of 3/4 is equal to the square root of 3 divided by the square root of 4, just based on properties of square root. And the square root of 4 is equal to 2, and so this is equal to the square root of 3 divided by 2. So, n is equal to the square root of 3 divided by 2. Therefore, the side lengths for this right triangle are 1 hypotenuse length, 1/2 hypotenuse length, and square root of 3 divided by 2 hypotenuse lengths. So let's see how this relates to the sine and cosine functions. We can look at cosine of 30 degrees. Cosine of 30 degrees will give us the length of this horizontal side measured in hypotenuse lengths, and we know that that horizontal side is square root of 3 divided by 2 hypotenuse lengths long. And therefore, cosine of 30 is equal to square root of 3 divided by 2. On the other hand, sine of 30 degrees will give us the vertical side length measured in hypotenuse lengths. We know that that's 1/2. Therefore, cosine of 30 degrees is equal to square root of 3 divided by 2. Sine of 30 degrees is equal to 1/2. Now, let's look at the 60-degree angle. We can just reorient this triangle. So I'm going to redraw this triangle down below, and we actually already know the side lengths. We already computed the lengths of these sides. I'm just going to reorient things real quick. Okay, so we have a hypotenuse length of 1 hypotenuse length. The vertical side is now square root of 3 divided by 2 hypotenuse lengths, and the shorter side, which is horizontal here, is 1/2 hypotenuse lengths. So in this case, we can say that cosine of 60 degrees is now going to be the length of the shorter side, which is 1/2 hypotenuse lengths. Sine of 60 degrees, on the other hand, will be the length of this vertical side, which is the longer side of this triangle, and that is square root of 3 divided by 2 hypotenuse lengths. And therefore, sine of 60 degrees is equal to square root of 3 divided by 2. So what we did was we found some exact output values. We found these ones for 30 degrees, similar ones for 60 degrees for sine and cosine. Now, you might also notice that 30 degrees is actually pi divided by 6 radians, and 60 degrees is pi divided by 3 radians. So we can actually rewrite these things. So we'd rewrite this one as cosine of pi divided by 6 is equal to the square root of 3 divided by 2. Similarly, we could write sine of pi divided by 6 is equal to 1/2. We could write cosine of pi divided by 3 is equal to 1/2. And sine of pi divided by 3 is equal to square root of 3 divided by 2. Now that's the same thinking, just using, instead of 60 degrees, pi over 3 radians. Instead of 30 degrees, we would use pi divided by 6 radians.